Again, this is part 2 of this, and it says find the sum of the positive integers from, so we want the sum from 1 to 100 inclusive, okay? So what we would do then, again, this would describe 1 plus 2 plus 3 plus dot 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 all the way to 100, where we would be wanting to find the sum of all these numbers from 1 to 100. So we are going to use our formula. So we would say, again, this is S sub n for the nth term here, the sum of the first n terms. And it would be n over 2, again, times the first term plus the last term. And so if I want to find the first 100 terms, the sum of the first 100 terms, I say S sub 100. And then in this formula, n will equal 100. So I say 100 over 2. And then I can write the first term in the parentheses here. The first term is 1. The last term is 100. And so the sum from 1 to 100 inclusive is this, okay? So I'm going to finish this out. 100 divided by 2 is 50, and 1 plus 100 is 101. And so if you were to multiply that, you would get 5,050. So that is the sum from 1 to 100. So it's kind of interesting. And then the last example that we wanted to do that's in your book requires a little bit more work because you actually have to find something first before you go ahead and find the sum. So it says find the sum of the series, and we have this series here. Okay, it's from 12 to 84, and they're counting by 4s in this. So I note that, okay, my first term is 12, my last term is 84, and the common difference between these terms is 4. So apparently I'm going to have to use that previous formula from the other video. A sub n equals a sub 1 plus n minus 1 times the common difference. I'm going to have to use this because I don't know the number of terms. And in my formula up here, if I want to find, remember, the sum of a finite number of terms, I need to know n. I need to know a sub 1 and a sub n. I know those two, but I don't know n. So I need to find out how many terms are we talking about. And you could technically just write them all out and then count. But there is a way to do this without having to do that. So a sub n is 84. And so we're going to say that a sub n is equal to 84. A sub 1 is 12. We don't know n, so we're just going to leave that as n minus 1. And then 4 is our common difference. Now, if we go ahead and solve this, I'm going to distribute the 4. So I'm going to get 4n minus 4. And I can then write 84 equals 12 minus 4 is 8. So I have that. I'm going to subtract 8 from both sides. And I'm going to get 76 equals 4n. Then I'm going to divide by 4. And I'm going to get 19 equals n. So we're talking about finding the sum of the 19 terms in this sequence. There's 19 terms here. So now we have enough information. So let's find the sum of all of those terms, all 19 terms. So that's a 19. And again, the formula is n over 2. So I'm going to write 19 over 2 times, and then I have to write in the first term, which is 12, plus the last term, which is 84. 12 plus 84 is 96. So this is 19 over 2 times 96. And when you multiply that out, multiply these two and divide by 2, you end up getting 912. So there you have it. That's how to find the sum of the first n terms of an arithmetic sequence. And again, this formula is right here for you, okay?